And good evening, everybody. Welcome back into the Dragon's Den. Sorry for being a little bit late tonight. I've been dealing with some allergies and sinus stuff all day, so after right near the end of work, I took a couple of Benadryl and took a nap. So hope everybody's doing well today. How's it going, Los Inc? Chewy, what's up? Hey, Nathan Bill Sings. How's it going? Otter's Danger Den, welcome in, welcome in. So yeah, I hope everybody's doing well. I'm gonna try and go for a little bit. We'll see how my sinuses play. If it feels like I'm gonna start doing a bunch of sneezing and stuff like that, I will cut the stream off and just sit there and be in sinus misery for the day. I'm, trying to get it knocked out with various things, but we'll muddle through. Pulled the trigger on a Core 1 this morning. Good for you. That is a really good printer. I'm happy with mine. I did mine from a kit build and did a 13-hour live stream and built it straight through, and then came back the next day. Came back the next day and did the belt tuning, which was really quick and simple, and been going on since it. Oh, sorry. Oh, there you go. Yeah, yeah. Hey, Eagle the Dragon, how's it going? We're doing well. We are doing well. Or as well as can be. We're going to see here. Yep. Give me a second. All right. Hopefully, thank you. My sinuses will play ball, and we can do some work tonight. Okay. That said, I'm going to switch the camera view. And this is kind of where we're at. We've got all of our ant head parts going on here. So let's just do a quick little mock-up to kind of give you an idea of what the ant head's going to look like there. All right. So that's what we're going to be working on tonight. I did go ahead and print off the parts for the extruder, just because all the parts look like they had been updated. Once again, I think this is the new parts for the wristwatch 2 extruder, and you can tell that there are differences in the parts now. So even though this was pre-assembled, I may need to go ahead and tear it down and reassemble it. Also, on our overall Micron, you'll see that I got our belts done up, and I figured out the issue. And on the Galileo 2 Z's, there was an inner bearing that's held in place with 3 screws. What was happening is if you tighten everything down, it pushes the planetary gear shaft back, and it's just enough that the rear of the planetary gear shaft catches on those 3 retaining screws that are holding the bearing in place. So I had to take everything apart and redo a couple of them, and I think at this point I've got them all to where they're moving. without jumping around and skipping. And I had everything nice and lined up, and then I just moved everything. So that's good. The other thing is I'm watching Steve Builds do his Micron Plus rebuild, and so I modified the electronics down here. And I will tilt this forward some and show you what I did. So if you can see the electronics things there as the gantry moves forward, let me slide that all the way forward and get it out of the way. So what he did was design this rear piece here, redesigned it so that we've got the two JST connectors on this side, a three-way on this side. This takes the two side blower fans in. This one takes the Nevermore fan in, and then we'll have 1, 2, 3 links that come out. Of course, this one being for the thermistor, and these 3 being for the bed wiring. That cleans all the bed wiring up and makes it a lot nicer and neater underneath. Rather than having one set of Wagos here for these fans and having to do a bunch of wire splicing here, and then having a 5-way set of Wagos going down the side. This cleans everything up and will keep all of the bed wiring forward of our hole here. And what I'll be able to do is come out directly with the ground, the neutral, and the live, and we'll be able to get this plumbed in right here, and we've got all of our main wiring done up to here. Then we'll just need to add our bed and our fans and stuff going down beneath. And in fact, we will probably actually go ahead and run this right now. Let me see. I just want to take a quick gander real fast. On these wires, they're coming primarily in from this side. Yeah, we'll be good. And there's nothing, well, there's a couple of wires coming in, but that's good. I was just thinking through it in my head if I could go ahead and cut these to length and kind of just keep them together and in there, and we can. So we'll go ahead and make these, go ahead and get these wires going. That way I can get rid of some of this excess that keeps flopping all over the place, and we'll just continue to work on. What do you want? Live, neutral, ground? Yeah, let's do that. Live, neutral, ground. I still haven't cut the ends on my Z wires just yet, just on the offside that we actually still need to go in and do any rework. We'll do this, and then we'll go back and we'll work on the ant head and get our ant head together. Now, I was looking at another mount, and I found a mount that should work with the ant head, and that it slides over the standoff, or becomes the standoff on one side between the motor mount and the CAN bus board for the toolhead board, and that will give us the ability to a little zip tie right there, and we'll be good there. To use the metal gantry mount, which is another reason why I haven't belted the XY yet. So some nice neat wiring there. Once again, we will be dealing with these wires. We're going to mount a GBB 15 right here on the underside of this main rail here. So we'll be able to bring this in. Our Y end stop will come here. We'll have a CAN bus wire that comes from this GBB 15 board that'll go into our wire chain down underneath and be our connection to the controller there. And then from this board will come up through the umbilical to the tool head, and that will give us that connection as well. Hey Spidey, how's it going? And that's the nice thing with the CAN bus, is you can continue to daisy chain it all the way through, and you'll be fine there. So, quick little bit of wiring. We'll build our tool head, and then with the tool head built, we will be able to go ahead and start installing that, doing some wiring, the whole 9 yards. Okay. Outside doing sanding on another project, not Master Chief. Okay, I'm going to assume that's for the misses, and you're trying to stay in the good graces. So that's a good idea. That is a good idea. We'll bring this up. We will come over to this view. There we go. So we've got our ant head assembly manual up here. I did download and print all of the new files because it looks like the majority of all the files was updated 3 weeks ago. Okay, so we're going to kind of work our way through here. Modular tool head allows usage of many different hot ends. The stock extruder of the ant head is the Galileo 2 kit used in conjunction with ant head's modified wristwatch variant. This functions like a standard wristwatch G2, but adds filament runout sensors to the extruder. The hot end, the stock hot end for ant head is the Revo. We're going to use the Piezo Revo for this. Hey Blue Chocobro, how's it going? Yes, so so if we come out here to ant head, or printers for ants and the ant head, you'll notice that the STLs were updated 2 weeks ago, and just about the majority of these were 3 weeks ago to 2 weeks ago. So I did go ahead, fixing minor offsets, this, that, and everything else. The one that you built here does not appear to have any wires coming out for any filament runout sensors. I know you said you did not want leaf cutter, so I did not print any of the parts for leaf cutter. And my question to you is going to be, I had a chance to drop in, yeah. My question to you is going to be, do you want me to rebuild do you want me to rebuild this wristwatch using the latest set of the files. It's completely up to you. I will go either way, depending on what you want me to do. So, like I said, this version does allow for the filament runout sensors, I guess. Yep, top and bottom. Hey, Pez Liz, how's it going? It is completely up to you. You let me know. Blue Chocobro. Oh, there we go, the Shure. So the Shure is to rebuild it using the filament sensors, because it would allow you a little bit more easily to just add leaf cutter down the road if that's what you want to do. And at least one filament runout sensor at the tool head, I think, is a lot better idea, because a lot of times on these, if you put, like on a V0, the original filament sensor is in one of the foots, which means you've got about 1.5 feet, 2 feet of a line from the filament sensor to the extruder. And once that filament sensor is tripped, it doesn't just keep going. You're out, right? So I like having it at the tool head, because you get a minimal amount of wasted material that way. Leaf cutter is a filament cutter that we just mentioned. Yay, a bunch of different screws, nuts, heat inserts. Because nothing says permanent like molten plastic and brass. And to make the tool head easier, we're going to be going ahead and installing the required heat set inserts for the build. Then build both sub-assemblies independently. Once complete, then we'll move to connecting wiring to the tool head board and all that good jazz. Okay, so it looks like we're going to do some heat set inserts. So let me pull this out. I know Projects in Dad's Garage was asking me if I had a Frax. I do. I have a built Frax. It is downstairs, and yeah, sitting on the kitchen counter. So at some point, I actually need to go through and get that up here and get it mounted to the bench somehow. Heat sets. Hopefully you have a good walk, Liz. Get a couple of these out. I don't know how many we're going to need. Looks like on this part, we're going to need one heat set insert right here, and the other one right there. So I'll get a couple of these put in. And for those of you that have been hiding, today was launch day for the Snapmaker U1. I do have access to the one at Ecovate 3D. I have not been able to go in and do any content on it. Every time I was there, somebody was doing content on it or had a print going on it. So I just have not been able to slice a print and get it going, because of course, the slice file is only on one of their machines. So I have to actually have the file there, or slice it and get it going. But if anybody is interested in seeing some prints off of that, just let me know, and I will be more than happy to go do some prints on that printer. Okay, and those two are in. Now it looks like we're going to need to side, put one on this side. Thank you for the follow, Lost Soul. How are you doing today? Hopefully you're doing well. Okay, and this is going to be a weird angle, so we're going to try and get this started. Get it close, soak a little heat in there, and then kind of hold it right down the edge to make sure that it goes in nice and straight. There's that one. Whoops. This heat set needs to be set not level with the surface. You will notice the wider hole width for the heat set goes more than halfway down the depth of the hole. Press the insert in so it goes to the bottom. So we need to embed this down in there some. So we will go ahead and make that go a little deeper in that hole. Okay, so we got that counter sunk down in there a ways. I'm kind of looking to see if I need to go a little, might need to go a little bit further. You got a slight little bit of expansion on the edge there. Try and burnish it down. Come back with a knife and just clean up that edge a little bit. But we're good there. All right, we have a print in place support that needs to be broken off. And it's this little piece right here. Should be rather easy to get off. That was really easy to get off. Check your edge. If it needs to be, just hit that lightly with a file. I'm going to go ahead and shut this off and move it out of the way so I don't burn myself. Just hit that edge a little bit with a file just to clean that interface surface up. Clean that up a little bit. And similar type thing on this side, this piece right here. You can see there's a little divot there. So there's some piece here. There's a little bit of a indent right there that we can use to get underneath it. There we go. That popped off pretty decently. Let's make sure that we get all of it off. Okay, we got those done. How's everybody doing tonight? I know we're getting a little bit later start. Remove the rubber seal, put the ECAS fitting in. I know you have one set up over here, but I will cover the other one because I have plenty of ECAS fitting from doing my box turtles. The question is do I have them right up here or not? And that answer is a resounding no. So let me find one of my ECAS fittings real fast. ECAS. Where are you hiding on me? Did you happen to have more ECAS fittings in here? That would be the easier thing to do. Not seeing any right off the bat. Okay, no worries. We can pop one in later. I know I've had like a whole bag of them over here from doing box turtles and stuff. Oh well. Oh well. Oh well. Oh well. You like how I say oh well and I just keep looking? No idea what kit that is, but back here in some old box turtle stuff. And there's an ECAS. And like I said, I know I've got I've got a huge bag of them because I bought a large bulk of them when I was doing all of the box turtle builds. So once again, remember to take off the little rubber piece at the bottom here. We'll leave that black piece on. So you want the small rubber piece, leave the black plastic piece on. Okay. And you may also need, because this is printed with a slight overhang on it, you might just need to clean up a little bit from the overhang so it's not, doesn't cause you any heartburn or problems when you're putting that in. Heartburn or problems more than normal. Which is the norm for ECAS fittings. And I can never tell, like especially on these, it's a weird geometry. I think I need to go a little bit more. We'll pop in our little blue piece, which sometimes goes in easy and sometimes goes in just as hard as the other part did. And once again, it doesn't help that there we go. It doesn't help that this is up on the edge and all that good stuff, but there's our little latching pan. And see, it looks like it might still be just a tiny bit proud. Come on, focus. Focus. There we go. See how, focus. It looks like it's just a little bit proud still. We'll see if we can't get that done just a little bit. See if we can't do that a little bit more, but I don't want to cause too many problems at this point. Oops. Now we've got the bearing support piece, and there's some stuff that pops out of here now. Hopefully this pops out relatively easily. Yep. Just like that. You can now see all the way through. Nice and easy peasy. Put a little bit of a file edge on there. Just be careful. We're just trying to get any raised burr knocked down. All right, looks like we're going to need 2 more heat sets on our fan pieces down here. So we'll get a couple more heat sets going. Hey, Projects in Dad's Garage, how's it going? Hey, Walter, you fell asleep and woke? Yeah, I came home, did the other meeting that I had, and took some Benadryl, and that's why we're getting a late start today. And yeah, we're working on an ant head here, Projects in Dad's Garage. So I sent your information forward, and the individual's like, could you have him contact me? And I'm like, I just gave you all of his information. Can't you contact him? Um, so Blue Chocobro, you tell me if you want me to do a leaf cutter or not. This is a build for Blue Chocobro. So that's this side. Take off the support. Yep, support's already gone. There is a little bit of support on the channel that needs to be removed. So these parts, when I printed them, they were down like this. I did have support right here on this tab that's already been removed. And I did print out two of these. One's for M3 and one's for 2.5 because I didn't know, it's been a while, since I did a Revo, and I don't know, I don't know which one it's using. It uses the 2.5 or the 3. This little sacrificial bridge needs to be cut, make it room for the hot end fan wiring. Okay. So we will cut that little bit of filament out. On both of these. So I gave her your information. She asked me to have you contact her. So I will now have to give you her information so that you can contact her. Hey, Big Jano, how's it going? Thank you for the 18-month in a row subscription. That is awesome. Yeah, gotta love people. Yeah. Insert pain smile here. Yep, Waters knows. All right, and now we're going to do a heat set on either side. So what we need to do is figure out, does our Revo use 2.5 or 3mm screws? Oh, it's not the Revo mount itself, it's the fan mount. So we can use 3mm screws and heat sets up front, or we can do 2.5mm screws and thread it directly into plastic. That's the issue, and I think what I'm going to do is set heat sets in here and use 3mm screws for that front fan, just because 2.5mm screws, one, suck. The heads are small. I hate them. If I can get away without using them, I will. And two, you're threading into plastic, so you get one, maybe two shots, and then you're reprinting this part. So I would much rather have heat set inserts in there so that we don't have to worry about fouling threads in a printed part and then having to redo them. I cannot express to you how many 2.5, screws I have shorn the heads off of. I have shorn the heads off of M3 screws, but let's be honest, it was doing M3 by 50 long screws. Oh, wow. Hey, Blue Chocobro just gifted 5 Tier 1 gift subs. Thank you so much. So, Otter's Danger Den, Lost Inc., Keza Colt, Projects in Dad's Garage, and 3D Medic Vents. Welcome to the crew. Welcome to the crew. You are now members of the Dragon Den. And how are you doing today, Jano? Hopefully you're doing well. Had to go unload the car? No worries. No worries. Understand family things happen. I will wind up putting a drill or reamer through the back side of that. Okay. So here you go. Which screws do I use? Depending on your 2510 fan you use, you might need 2.5 screws that go directly into plastic or M3 heat sets. We're going to make sure that they are M3 come hell or high water. And cutting edge technology. If you're installing the leaf cutter, filament cutter, there is a flanged M2 heat set that gets installed in the filament path. After the heat set's installed, it's recommended to drill it out to 2mm or using a 2mm drill and chamfer the opening to help with filament loading. No blade, no problem. If you're not using leaf cutter, it is recommended to drill out the filament path with a 4mm drill bit so that the PTFE tubing can pass through into the hot end. That sounds like a perfect plan. And because we're not doing leaf cutter, right? You're fine skipping leaf cutter. Okay. No intents of putting a box turtle on this, huh? No, we're good. We're good. Okay, so we're going to need a couple of our pieces here. We've got a 4mm. Yeah, a bit of a travel printer. So 4mm, I'm using a reamer, not a drill. Okay. And I'm just going to do this. That is not straight. Straight up and down. Now, we use a reamer because it ensures that you get a nice, clean, round hole to final spec tolerant, which in this case would be a 4mm hole. If you're using a drill, it's going to always have a cutting face that's biting in versus the straight-edged reamers that I'm using. And you will always, I'm not going to say always, a high percentage of the time you will be cutting a non-circular hole through your printed part. Portable box turtle is what you're hearing. Box turtles are pretty portable. I mean, I'm going to tell you that. They're pretty portable. That is a pretty tight M3. So the problem I'm having or looking at is this hole is pretty straight through, right? Come on. This hole has a little bit of blocking material on it. So that's what I was trying to do, is knock that out. And at the same time, as I started to look at that and drill it out with the reamer, I was like, that may be not a good idea. I don't know yet if these are 3mm pass-throughs or if these are screw-in at that point. So we will hold off on that 3mm for the time being. So like I mentioned in Projects in Dad's Garage, his stream this morning, downstairs I did get the Ender 3 NG kit in. So I've got all of that and some of the extras, panel kit, the bed carriage, the Mic 6 build plate. What I didn't get, because they didn't have it, is the heater for that Mic 6 build plate. So I still need to look at that. Oof the May. Be careful, you're going to want to push heat sets from the bottom side of the top surface. To do this, you'll have to use your heat set tool. Oh, this is the main part here. Okay, wowzer. Okay, so we're going to have to put heat sets here and here, here and here. Now you'll notice that both of these, that is full plastic, full plastic. Over on this side, full plastic, and this edge, that's not full plastic all the way through, right? You see that that's not a full plastic all the way through piece there. So we got to be careful we don't blow that out. And then also, we need to put in one on this wing and one on this wing, and there's no way of really getting in there. Now what Steve Builds did was put the heat set in and screw in the brass screws from the removal kit, heat that up and pull it through. That sounds like a fantastic plan, except my M5 adapter for my removal tool has not come in yet. So we may have to do something a little different. And I need to, my overhang here could have used a little bit more cooling. And this is going to be a slot where wires are going to go through. So let me smooth that edge over some. Okay, so we'll bring the heat press up here and we'll start doing some more heat presses. Or some heat inserts. We'll need to get a little bit creative on doing these two here and pulling them in from the opposite side. But it is 1, 2, 3. Oof. Okay. Hey, Additive Adam, how are you doing today? Hope you're doing well. We are doing an ant head build. See if I can pull you all in a little bit closer here as I go to do this. And we'll see if I can't try to burn the crap out of myself trying to do this. Okay, so we need these two sides first. And of course, there's no nice way of setting it down on there, so we're going to freehand this a bit. Hey, Pete, how's it going? Hope you're doing well. Kind of missed your comment earlier because I don't know why my brain just saw Chewy's and thought the one right up above it was probably a Chewy comment as well. And you'll notice how this one here gets kind of set down on this back edge. It's down in there a little bit more. So you'll get this one started, and then I just brought in the back side of my tweezers, pushed it all the way down in there, and that way we got that down in there. Now we need to come in from here. I'll come in at an angle, and once again I'll use my tweezers to try and get it straight. Or we can pull out our copper screws, which will give us better transfer, and try and do a pull through. But I think at least on this side I should be able to get a good amount of heat in it coming in at an angle. It's just making sure that we get it nice and flat in here. Okay. This side is going to be a lot more of an angled end, so we'll see how we're going to do there. Not too shabby. So we came in kind of at a very obtuse angle, right? Very obtuse angle to make sure that we don't melt this side. Get it partially down in there, then come in with our flat object, kind of push down on there, and that will help get it nice and flush. So we get a good flush heat insert there. So we got 1, 2, 3, 4. The one in the middle we're not doing. We're going to do another M4 ream. And now we need the 1, 2, and then one into the back here. So we've got a couple more to put in here. And if you all are, if you guys have good eyes and you're looking and paying attention, you will see another new affiliate code that pops up. So last night I got an affiliate code for Voxel PLA. And while I have not used any of their filament yet, I have used their drop-in replacement filters for the P1 and X1 series. So they have a drop-in replacement filter for the bamboos, and that drop-in, where the bamboos is just a carbon filter, the Voxel is a half carbon, half half carbon, half HEPA filter. So that one's down in there nicely. Very nice. So there we go. We've got 2 on that side, 2 on that side, 2 coming in, 1 there, and the 1 in the back. You fell on your butt at launch or lunch. Hope your day goes much faster than mine did. Uh-oh. Yeah, what were you working on, Chewy? Should I look for one that uses the bamboo style hot end? One what? One that would use a bamboo style hot end with a cutter? Jabberwocky uses a bamboo style hot end and includes a cutter. So this one is still a little stiff. I need to work on that, but there's Jabberwocky. This uses a bamboo style hot end. In fact, it's a Fadus conch hot end and a Nighthawk board. I think this may be all of the heat sets. Now, this was the board that I printed out that would require 2 heat sets at the bottom. There would be no heat sets up here because they would use the drop-in nuts, and that's for the screws into the front here. But we'd also have the place to mount our board. But I did find these little parts that would go on the standoffs. You put a heat set in on each side, and this would act as your standoff and would allow you to mount your board right here for the piezo sensor. So we're going to try this first, and if that works, then rather than using this X carriage being the printed X carriage that I just showed you, we would be able to use the metal carriage that you bought Choco Bro, or Blue Choco Bro. So we'll hold off on that for now. That's the 2020 X carriage. We are not using that. Ants on a log. That should finish all the heat sets and support material. You can move your heat set tool out of your workspace and let it cool off. Thank you for letting me know that. That way I try not to burn myself. You'll also want to give your heat sets a chance to cool off. It's a great time to find a snack or refill your drink or whatever for the next few minutes. That's great too. Your favorite snack is ants on a log. If you need instructions on how to make this wonderful snack, you're in luck. They provided some in the files. Looks like raisins on peanut butter on celery, from the look of it. That's a little disturbing. To do hot end render. So there's no hot end render there. And speaking of which, I mentioned Voxel PLA. There is the Voxel PLA affiliate link, which appears to be broken. Oh, that's sweet. All right, give me 1 second and I will try and fix that. I think there's a slash missing. Though I don't know. Let me give that link there a shot. See if it works. Yeah, that. Nope, there we go. It does add the slash in there. Okay, so somebody can do a bang. What is it? Bang. Voxel, VOXEL. And let me know if the link fully works now. Looks like it works now. There we go. Awesome. Thank you, Blue Choco Bro. So yeah, Voxel, I just scored an affiliate code with them. I plan on getting some of their filament and working on, trying out some of their filament, just base colors right now. And like I said, they've got a lot of stuff there for the bamboos and stuff like that. There's some really cool stuff out there as well for various printers. Hot end mount. This shows mounting the hot end in there with some M3x8 button head cap screws. But before we do that, we need to actually look at the E3D Piezo stuff. So, since we're going to go take a look at the main display, once again, Voxel PLA. I know that ModBot has used the filaments and really likes the filaments. I tend to come in here and look for things like I am running a bento box too from them in my X1C, in one of my X1Cs. I am running their filter, which is a carbon combo with a HEPA 13 filter. So I'm using that. Uh-oh. Bruised but not broken, you'll be fine. Uh-oh, what happened, Adam? I hope you mend quickly. I have no experience with the Python. I believe Waters has, or the Hula itself. I know a lot of people were doing Hula. I just let mine shake the entire workbench. But there was some interesting parts in here, such as Bamboo Lab X1P1 series drawer hardware kit, HPV drawer and pipe hardware kit, A1 and A1 mini drawer. And you're like, what the heck are those? So these are some decently killer designs, right? So if we look at these. Where's the link? There we go. CC3D. So CC3D, darn it. Let's go to the main CC3D. Oh, darn it. What did I do? Get rid of the extras. Yeah. I don't know, it was just out there. Maybe that's a bad link. So CC3D projects. So CC3D, so basically what Voxel has is hardware kits. Oh, it's his birthday. You get 80% off of his files today. But what he has is 3D printable files for a lot of different models. Yeah, glad you're gonna be good, Adam. That's great. Hands free for a bit. Need to change over to your PC. Phone's about to die. Gotcha. But what they've got here is various models for different printers. So I was over here looking at these models. So this is for an X1C P1 series. It's a drawer system. You've got the back pipe for the poop chute or a left drawer pipe setup. And what this allows you to do is have a side of the drawer that is all poop chute. So you don't have to reach around back and do things like that. It's all coming down into this bottom drawer. And the other side, you get storage on it. You've got a drawer stacks set up, some Hulu feet, you name it, you got it type setup here. And there's different versions of it that you can use. They even have like an H-Dry light AMS or Hydro Dry box. So various things here, mufflers to cover up the fans and reduce fan noise. They've got stuff for the A1. They've got A1 Mini, the Elegoo Centauri Carbon. I am considering getting this muffler and trying it out. The fans on the Centauri Carbon are loud. They're annoying. That's the biggest complaint I got with the Centauri Carbon is the rear fan. And I've seen some mods to work that go on the inside, but this will be the first one that does something on the outside. So I'm interested in taking a look at this and giving this a shot to see how well it works. I mean, it's €2. So I've got 4 Centauri Carbons. If it works, it works. But once again, they have the full drawer system, and that drawer system, yes, 80% off. It's your birthday. Got it. So you've got the muffler, you've got the rear poop chute down to the drawer, which raises your overall printer stack up. It's got a 2-spool dry chamber, so you can have one spool active and another staying there dry. Hulu feet option to the drawer, build plate holder on the side, glass riser. So basically, you can pimp out your ride. But what the nice thing with Voxel is you can get the screw kits and magnet kits, so you don't have to try and go and source all the hardware. It's already done for you. You just select which hardware kit you need and go on from there, was kind of where I was going. But it looks like you can get the hardware kit from Voxel, which is a stateside company. They're out of California. and you can help out the channel if you use the affiliate link. And then you can come over here to CC3D, and apparently you can get 80% off on the files today because it's his birthday, or their birthday. Now, all of mine are kind of low. I don't know if the drawer would be a useful, I mean, it would be useful to be able to pull the actual poop chute stuff out. Like I said, it looks like a pretty decent sized drawer. And you've got a compartment on the other side that you can store a bunch of stuff in and things. So it is pretty neat. I do like the overall concept of these and the ability to pimp your printer out however you like. It's just something to be aware of that files are out there. So anyhow, with that being said, let me close these links. We need to look at the E3D piezo sensor. What is going on? Wow, that was interesting. My space bar just got stuck. E3D, and it did it again. PZ. Whoop, dang it. I have no idea what's going on with my keyboard now, other than there's got to be junk in it. E3D. What the hell? Okay. Really what I'm trying to do is find the instructions, and my keyboard's doing crazy things on me. Do I need a custom keyboard? You might know a guy. You know what? You know what? Maybe. Documentation. What's in the box? Really don't need the data sheet. What I need is install. Rated at 5 volt. Do not send more than 5 volt to it or it will damage things. Impact trigger that simulates a switch and can replace boron tap and other Z probes. Has LED indicators. Press the button to select the configurable presets. IIR filter to increase noise immunity and noise rejection. Supports both UART and I2C communication protocol. Voltage range of 3.3 volt to 5 volt. Reverse voltage protection. Safety trigger during communications. Good. The table below displays the minimum force required to trigger the PZ probe for the highlighted speeds. So these are some of the presets that we'll be able to flip through. And I'll be quite honest with you, I'm going to see what Steve does, and that's going to be my starting point. I mean, quite honestly, I'm going to tell you that right now, Blue Chocolate Bro. That's going to be my starting point. There's a setup guide, connecting it to your printer. The heatsink is mounted as with a normal Voron heatsink. It has a wire with a 4-pin connector coming out of the central body. This will be referred to as the flat flex. Okay. Not me watching Digital Dragon while I watch Digital Dragon. Gotcha. Exactly. I'm like, people have gone before me. I will look at these things. Finding your toolhead assembly for the Baby Belt Pro. It's in the video series. The PZ probe board can then be connected to the cable with the 7-pin connector as shown in the image below. To see the pinout of the connector, please see the pinout tab later in this guide. Yes. UDPI connector, I2C connector. Here's the breakout, blah, blah, blah. Board mounting. You've got these two little tabs that can be used to mount the board, or it looks like you can M2 machine screws to mount that in a convenient place on the printer. Since the area around the mounting holes is clear, they can also be drilled to accommodate M3 screws. That's nice. If you're mounting it to a Voron, you can mount the board to the X carriage using the modified 3D printed part. That's cool. Nice. You can attach with double-sided tape to the back of the PZ probe board, then place it in a convenient location on your printer setup. You can then break the PCB part of the M2 mountings off and go that route. Okay. Firmware setup, stuff like that, troubleshooting. Okay, so I guess let me just, there's really not a lot to see there. So let's grab the parts. We've got the get that keyboard out of the way, which by the way is an old Logitech. So this is kind of my standard keyboard. And quite honestly, I've got a second one sitting over there. Well, over there somewhere. Over in this mess because work bought me one. So I had one at the house that I used that I bought. And then there's one over there that work paid for that I could dig out as a spare. Or just clean whatever's sticking there. So in the Voron, we've got a 0.4 standard nozzle. We've got our beautiful machined and anodized LDO top, and this is the 60-watt variant. Is 60 the 60 is the high flow wattage, right? Put this back down in here because I'm not going to need it just yet. And then we've got our Revo PZ Probe Voron. So let's see what all we have in here. Two tiny M2 screws just hanging out loose in the bag, because why not? Perfect. We'll grab these heat sets and put them back in here because it looks like we'll be done for now. Okay, so we've got the piezo probe in here. Oh, and this is a full setup, so we won't even need. There we go. I didn't realize that was going to be a full setup. So the LDO Voron one has a tumbled anodized texture, so it's almost like it was done on a textured build plate, right? Slight little bit of texture to it. The E3D one is nice shiny, like it was done on a straight PEI plate or a piece of glass, and it's got the piezo sensor already mounted in there with that flat cable. So we're not going to use this one at all, which I was thinking that it was just going to be like the sensor, and I was going to have to do something to the mount, but we're just going to use this whole mount here. So you'll get a spare heat sink back, Choco Bro. Okay, and then we've got plenty of cables. What I didn't see, so cables. Yep, nothing else in there. Where's the little board? Did I take the little board out? Little board, oh where art thou, little board? I don't think I took it out. Because I would have had no reason to take the board out. Here's the GBB 15. More LEDs. UTFE, fan. Um, um, Blue, Chocobo. Did you open this up at all? Might you have the little board? Stops, PSTs, Legos. That. This was, what was this again? Oh, bed mounting stuff. All right, folks, I am digging around in all the boxes to see if I can find the board for that. Otherwise, that's going to be an issue. And I am not seeing the board in here at all, which makes no sense. It should have been in the package. I will continue doing the build, but that's something we're going to need to look at, Zura. Goes in with M3x8 button head cap screws. the board that the PZ probe goes into. I do not have that in here. Because this is the Revo Boron with Piezo Cool Side kit. It has the piezo sensor already in there with the flat cable. And there's various other cables in here, like extension for the thermistor, extension for the heater, and then this is the sensor cable that goes from the other side of the board, but I don't have the actual board. Yeah, that's not ideal at all. Not ideal at all. And I think I am going to have to put this in just to make it easier to do the install. And did Blue Chocobro have to drop off? I don't know. We'll have to figure that out. So go ahead and get that popped on. We'll get this standard Revo nozzle installed. Nope, not standard. That's an Obsidian. Or, yeah. Maybe a high flow. Am I going to be around after stream? Probably. You've got assembly questions on the Baby Belt Pro. Okay. All right, so this is now run in all the way. I've got my wires kind of coming out towards the back, kind of in the same direction as my cable up there is. We're going to need our top mount. Now, the tab is at the rear, so we're going to want this to come in there. And this is going to basically snap fit into the part. And if it doesn't, don't force it. Come back and you'll see once again that this side there's a bit of overhang floofage, maybe if I can get the light to hit it. So I'm just going to take a knife and clean up that edge just a bit. And it should fit down in there nicely. And that's all that we're trying to do. We don't want to take too much off. We're just trying to scrape this down so that we get a nice tight fit and everything lines up. And the other thing to remember to do before we actually mount this is we're going to take this, slide it in, get things lined up and slid in. Because remember, we came in through here with a 4mm, and we need to do the same thing here. So having this as one piece when we ream it again will ensure that we maintain that straight up and down. I'm going to need to extend this out some. And I just realized that's the 3mm, not the 4mm. So let's actually use the 4mm. I'll have better luck doing what I was trying to do with the 4mm, which is ensuring that I have a nice straight 4mm path for the PTFE tube to go all the way through both of these parts that have just now been nested together. We just reamed all the way through from the back side that we had reamed previously. So I reamed all the way through to the front, which means now the PTFE tube get the little bird lip off the edge there. Good, now I'll be able to go all the way through. Really, is this like ever so slightly thicker than 4mm? Maybe. It is a very tight fit. It does go, but it is a very tight fit. If that's what we're going to want, is a nice, good, tight fit of that 4mm Bowden tube, because that's going to give us our constrained path all the way through. Yeah, by the way, Waters, Blue Chocobro is part of the Princeps team and is working on some of the Babyville stuff. So, Blue Chocobro, since you're here, so we've got the cold side with the piezo sensor. I've got the hot end, the thermistor, and the other wire in here. What I don't seem to have is the board. I don't seem to see or find or have the board for this. I'm not kidding. I can't find it. Can you check to see if you've got it? If so, that's not a big deal. We can figure out how to get it to me. But I am not finding the board at this point in time. I don't remember ever taking the board out. What I was doing was I knew that there was a board that needed to go in here. And I don't remember ever pulling the board out of the package. So if you would mind, take a look and see if you've got that board. And I will also continue to look and see if I do have it somewhere around here. Hell, I might even go and take a look at my old video streams to see if I've showed it on stream, because if so, then it's somewhere over here and on me. Because this is the cartographer. Yeah, it's not majorly critical just yet. We've got time. We can look look for it. That was a bright thing to do. All right, folks, I'll be right back. I just slipped myself with a brand new blade. Yeah, it would have been in the bag with the rest of the Revo. That's not here, and that's the only thing left in the other bag with the Revo. So yeah, give me a second to take care of this, and I will be right back. I'm going to put you guys on mute for a moment. Okay, I am back. Sorry about that. Dragon sprung a leak. Yep, it's not a build unless you bleed during it, right? Okay, so all the wires I believe are heading out the back, because we will have this little channel here that goes from front to back. And so this should slide right down into that head there, or in the top there, there's a little recess. It's the exact size of this. So if we got things cleaned up a bit, it should align right in there and kind of snap in. And it's still a little tight, so let me use the device of pain and clear up the other side of the face. And go slow. You're trying not to weaken the overall part. You're just trying to take a little bit off the edge here so that the part can slip in and clip in. Front, back, side to side. I'm just going to take the heater back off. All right, sounds good, Zura. I'm trying to be extra careful so I don't damage one of the wires or especially this particular wire right here. If you damage this flat cable, you're just kind of SOL. You just made a mistake, right? So we're trying very hard to make sure that we've got a clean spot for this to come down into. And if that means making a little bit of wiggle room, we'll make a little bit of wiggle room. Take your time, creep up on it. No sense in trying to knife out a big divot because then you're just going to make too much room and it's not going to be a nice steady fit. It's right in the corner where it seems to be like catching. Like the front to back dimension is good. It's the actual corner, the rounded edge, that needs a little bit of love. Wait, blue is, yes, blue Chocobro is Zura. It took me a while to catch on to that and know that he and Zura are the same. And he has a different name on Discord, which was throwing me for a loop as well. All right, why? Okay, we're going. I think we're just going to try and pull it in with the screws. We're close enough now that that should be able to work. Of course, it says to use button heads, and the button heads are not going to work. We're going to need socket heads, I believe. You're going to make a pizza real quick. Okay. Yeah, he's Zura in the Princep Discord. Yeah, that's what's throwing me off, is he's using different names in different locations. Okay, so once again, it is showing button heads here, but that's okay because socket heads, there's enough depth in the mount holes that we can go with either one. Once again, I'm switching over to socket heads because the button heads are a little bit wider at the top or in the head than the socket heads, and I'm not going to sit here and try and just let me drill out or remount the hole. Nah, we'll just call it good, switch the screw type up. It's all good. Make sure that these are tightened down with the elbow calibrated number of ugga-duggas. And we'll let you see how we are there. You can see the screws just peeking out the back. Everything's nice and level in there. And our wire's just going to be able to sneak out around the edge. Okay. Put the blade thingy away. It goes away. X carriage. Dangerous skull alone, take the right carriage. For Micron and SF, continue to page 32. For Voron, B2 Trident, go to 36. We're on page 34. Micron carriage assembly. Put in some X nuts. This would be a tool head's emotional support bumper. If you are not using sensorless, the X-in stop gets installed on the probe mount using one M2 self-tapping screw. The other probe mounts are similar with the switch on a different orientation. That and that go together to form the pub thing. You need to reprint that because that looks like what? I don't think I printed that out. Because I didn't. Unlike the other probes, the mount for beacon cartographer needs to be installed through the beacon cartographer prior to mounting the probe using the two M3x8 button head cap screws. You feed. Oh, okay, I got you now. That's on the actual. That would be mounted to the actual printed part, and if we're going to be able to do the other carriage, we're not using beacon or cartographer. (2020) carriage assembly we're not using. Okay, here we go. Hot end mount. Use two M3x25 socketed cap screws to mount the hot end to the carriage assembly. We have not installed the carriage assembly yet. All right, let me take a look at this real fast. Sorry, I'm looking through here to understand. Hey, my light, how's it going? Your water's everywhere? Yeah, there you go. I'm just kind of looking through the ant head assembly because we have not belted our carriage yet. And I'm just looking at the way that everything is mounting in there. Bowden tube. All right, now it gets down into assembling the wristwatch. Filament run out above and below. Hope you're doing well, Mod Light. So what we have is, I believe this is a standard wristwatch or G2 wristwatch, or maybe even an older version of the one that is designed for the ant head. It should all mount the same? Yes, the mounting holes are in the same location. So our option is just go with this one in the way it is, or we can redo it with the parts that I printed out and put some heat sets into. It does have provisions for filament runout switches. 2, one before, one after. We're not using the filament cutter. I prefer to have filament runout switches, at least at the tool head, at least one of them. And what I'm going to do is I'm going to take a look at the EBB 36 board here that we're going to be using. And I need to try and plan some things. What is it? Okay. So from an EBB 36 perspective, we've got our motor, our hot end thermistor, fan. I'm going to pull this up. EBB 36 CAN 1.2. Let's pull that up and make sure that we have all the connectors that we would need. CAN V1 and 1.2. 36. And hey, Westry, how's it going, sis? Stopping by before you hit the hay? Well, don't hit the hay too hard. It might be painful. Okay, so I'm just trying to look and see what all we have. So, of course, we've got our stepper motor up here in the top left. We'll have, of course, the CAN bus connector, hot end, fan 2, fan 1, and our thermistor. So we've got 2 fans, so we're going to have to mount, or we're going to have to put our 2 cooling fans together, and the hot end fan is going to come in separately. We'll have a probe port, and that would be the quote-unquote BL Touch. That would be, I believe, what we're going to use for the PZ board. We would have the end stop, so there's 3 different end stop sensors there. There is RGB capability, so we would have the RGB header for the LED lights. I'm assuming he wants LED lights in it because I've got sequins and standard LEDs. I do have the a jig here for mounting the LEDs to get the right spacing and wire between the 2 or the 3 of them. And I see 2 pins. So we've got an X. Y is built in on the gantry, so we need an X and at least 1 filament sensor, if not 2. So we do have enough in-stop pins on this white connector here, this 5-pin in-stock connector. Once again, the DuPont connector down below will be for the probe pins, which would be our piezo sensor. I believe that will work. There's a lot of wires coming out of that. There's a lot of wires coming out of that. So we do have the options there. Let's see. Back to the piezo probe. The cable has 4 other connectors, each with their own functions. The in-stock connector. If you're using an Octopus board, for example, this can plug straight into the in-stock. UART connector. If you're using a Raspberry Pi, this can be connected directly to the pin header of the Pi. UPDI connector. Or an I2C connector. So it seems like the easiest would be to install it in with the 3-pin connector. Thanks for the lurk, sis. Have a great one. Get some sleep. Mia says hi. Give her some hugs and kisses and love for me. So this is doable. We can figure out the wiring and how to do the wiring. The biggest thing is figuring out where the little board is, because I do not have this little board in this kit. It is not here. So I think I'm going to have to take a quick gander at Steve's build and see how he wired it up. Or look right here, which is where somebody else had done it. So 3 wires up and down. What board is that? All right, yeah, he's using a Nighthawk 36 board, which is what Steve's doing as well. So that's a Nighthawk 36 board, but he is just using the 3 pins that come up. So that would be the 3 pins into an in-stop sensor, and I would bring it into the probe and use PB9, 5 volt, and ground, which would be these 3 bottom pins, or the 3 the center to the right on that bottom DuPont connector. And then the main in-stop pins up here, which is 5 volt, ground, and PB6. We would do X and a filament sensor. Shit, for that matter, to make it easier, we could just use this one in-stock connector. We'll have power, ground, PB6 we would use for the PZ probe, PB5 we could use for the X end stop. PB7 we can use and do a filament runout sensor above the gear. Below the gear, we would add a filament runout sensor, I believe, and just yeah, we would just put a filament runout sensor in there and just not wire it up. I'm trying to think through this in my head and just really say, do I want to rebuild the extruder that he's already got built or leave it the way it is? I think looking at this, I should have enough connectors easily to do everything on the board. Once again, the fans I'm going to have to splice together. The Nighthawk board's nice because it has 2 different fans for part cooling. But here we're going to have to split them together and run them into a single fan input. Which is fine, it's doable. Sorry, I'm just thinking through some things in my head here. Yeah, and see, this is where I'm saying is, this is, I'll say, the newer wristwatch design versus what Galileo 2 wristwatch. And I think he's just got an older design. Yeah, I think we're going to wind up taking his apart and doing the new one. The only difference is the ant head has the provisions for end stops. This one does not. So, or I'm sorry, well, I say end stops, but I mean, you guys know what I mean as far as filament runout sensors go. So let's come back over here. We've got the ability to do 2 filament runout sensors. I only want to use the one above the gear because we'll be using this as a true filament runout sensor, right? If we do it below the gear, that'll be useful if we're doing the cutter, but since we're not doing the cutter, we won't have that, we'll say, quote unquote, installed. I will install the physical switch. I won't wire it up. The reason I'm going to install the physical switch is if I don't have the ball in there, there is the chance for the, if we don't have the spherical bearing and the switch in there, there is a chance that filament can squirt out right here. So we need to at least have the physical install there. If we don't, we'll run into problems. Now, I've got 2 different size ball bearings here. And does it say what size? Yes, 5.5, which are the ones in the bag. These are 5. The ones in the bag are 5.5. Box Turtle uses 5s. anything to do in a Voron situation or ERCFA would use a 5.5, hence why I've got some 5.5s here. So we've got 2 ball bearings. Let me put that somewhere where they don't go running away. I'll need 2 switches. And we're going to use a little bit nicer switches than the standards. You know, all those have the heads on them. Okay, so I got to take the lever off of one of these. There we go. M2x10 self-tapping. $5mm driver. And we're going to need a ball. We're going to drop that down in the opening there. So bearing goes in. And apparently those might actually be too big. Are they the other ones? Huh. It does say 5.5 right there, but that is definitely slightly too big to fall down in there. And where that one fell right in place. So we're going to use this one. The other ones might be 6s. And once again, this one here at the bottom that we're putting in is not going to be wired up. It is literally just there to keep that ball from running away and keep a constrained filament path for our hot end, or excuse me, our extruder. And let me grab a small piece of filament so I can just listen to make sure I'm getting a good click. How do I not have a small piece of filament readily available? Oh, there we go. And of course, right as I say that, the AC kicks in. Trying to make sure that my filament path stays fairly constrained. Okay, that is working, so that's good. Now this next one we're going to need to actually do some wires on so that it's ready to go and we can wire it in. So we'll need 2 wires, a negative and a positive, or a ground and a trigger pin. How's that going to work? Yep, don't worry. It'll work. That's what we're going to say. We'll make it work. I do not lose those little 2 mounting screws. I am going to put them back in here with the wire and the PTFE tube that came with our Piezo cool side. We need our soldering stuff. These back away. This stuff. Yeah, check these. These might be 5mm, or I'm sorry, 6mm bearings instead of 5.5. Okay. That there, this here, 2 wires of a decent length, preferably of a small gauge. Not thermistor wire. I mean, it's an end stop, right? So I'm going to take just a piece of fan wire. It's an end stop. It doesn't have to be anything big. So we'll use, well, black and red, we'll use red for the sensor wire and black for the common. We don't need much stripped off of these. Make the connection. We'll pull them back some so we can put some heat shrink on them. Then we'll cut it to length once we get there. Once we get there, meaning once we get to doing the wiring at the board, we'll cut that wire to length. And looking at the way the other one went in, I am going to try and snip just a small portion off the ends of these. Give myself a little bit more room to play with in the tool head. And I'm also going to cut the center pin out completely. Once again, to give me a little bit more room to play with there. So we just trim those wires down, or the legs down a little bit. For 300C, we're going to Just tin these legs. We'll tin the wires. Put a small piece of heat shrink tubing on there on each side. And then we'll make our connections. Once again, I said the red was going to be the signal, which will be the side closest to our plunger. Another one goes to the other side. We'll pull up our heat shrink. We'll remove the hot stuff. Let it cool off over there where I don't burn myself on it. Since I've already had a hard time and cut myself tonight. Break these down. These are soldering wired pigtails into the switches on the outer two legs. Before mounting them, make sure the pigtails have enough room to route through the extruder and reach the tool head board. Once that is done, insert a ball bearing into the hole to the left of where the switch will mount. Place your switch. Yep. Okay. So we've got a pigtail on the switch that should be plenty long enough to get there, especially since we're doing it at the top and our wiring is going to come up and around. So ball bearing goes in the hole. Ball bearing goes in the hole there. So like that. Make sure it goes down in there. We'll put our in-stop in with the plunger lined up over that hole. We may have to bend our wires a bit here, which is another reason why we remove that center pin. To give us the ability to route our wires. Get in there. There we go. And then we'll screw this down in there. You just want it to be snug. Don't go in there and try and ugga-dugga it down. You will fracture the case. And if you fracture the case, you're probably going to have an issue getting things to work appropriately. And I may need to go in there with an Allen key. Darn it. Here we go. Okay. So there is our two clickies, one at the top that's wired in, one at the bottom that's just, there's a placeholder. We'll take our filament, which is a straight cut at the end. So let me get it a bit of an angle cut. Make it a little bit easier on myself. We'll run it through. All right. I am hearing clicky clicky, so that's good. You can also use a small Allen key. Yep. We're getting good clickies, so that's good. Hi, Steve. Hi, Steve. Hey, Steve Builds. How's it going? I hope you're doing well. I am kind of meandering and muttering through here. We've been working on putting together the ant head extruder component, and we had a pre-assembled Galileo wristwatch, but it's a slightly different version of the files than what we have here with the newer files. And so while it should work, I decided I was going to take it apart and redo it with the latest versions. It could be good, that could be bad, I don't know, but we'll see. Hope you're doing well though, Steve. On your words on stream sometimes. On your build, when you did the lights, did you just use this jig to set up your LEDs to do your lights for it? I did not watch all of your stream, which is what I'm basically getting at. Is I did not watch all of it. We are doing the PZ mount, so, but we're using EBB 36 CAN bus board instead of the Nighthawk. Whoops. Okay, so what I was saying was, so I had a Galileo 2 wristwatch that was pre-built, and it looks like the files have been updated in the last couple of weeks. So I did reprint all the parts, and we're rebuilding it. And of course, we're rebuilding it with the ant head versions that allows for the end stop in the tool head, or the end stop in the tool head. The end stop, which acts as a filament sensor in the tool head. So what I did was we're only going to use the top one, which will allow us to get filament run out and still hopefully unload. If we use the lower one, by the time it trips this, it's past the gears and we'll never be able to do a retract. So we're doing this. I'm just using standard end stop wiring. I'll cut it to length here when we get there. But I'm redoing these. I had to reprint the files because it looked like, based on the one that Zura had pre-assembled, that this is older files, and the files have been updated in the last couple of weeks. So, very, very long way of saying I reprinted the files. And damn, that is a different size. That sucks. All right, well, at least that was easy enough to push out. There we go. Did you have any issues yet with your piezo probe? It's kind of the question of the day. We are, other than the fact that I don't know where the board for the PZ probe is, yeah, we're doing well. All right, which way are you going in? Hello? Old part. Old part. Old. Galileo wristwatch. We inserted that. We inserted that. We're taking this apart. And of course, that's going to be too big. Hey, Zombie, how's it going? We are disassembling the extruder and rebuilding the extruder. I have not set one up before. Is it my understanding that the ribbon cable goes to the board, and then out of the board, you've got a plethora of options, and it can be connected in just like a standard end stop? Is that correct? Takes no more than 5 volts, and it connects in just like a standard end stop. Okay. Yeah, the PZ. And yes, there is a set screw in there. See why I pulled that off instead of that. Eighteen extra volts? No, thank you. Do I need a mount for the board? So I printed this little guy out initially because it did have a spot to be able to mount the board in the back. So Zura provided a honey badger carriage, and my fear was I wouldn't be able to use it because there would be no provision to mount that board on the back, right? But I found a mount like this that acts as one of the standoffs behind the motor that will allow you to mount the board right there with the M2x10 screws. So my plan is to use this. Yeah, now I've got a couple of beacons and I'm really liking the beacons. Yeah, that carriage is really good. So I've been holding off on doing the XY belts because I was really hoping I could figure out a way of mounting that board to let me use this carriage. And it seems like I'm going to be able to now. So we'll be installing that. Now, the concern I have is I've got everything for the PZ except the little board. So we're going to have to do some hunting for said board. Okay, so we've got the 3 gears. We need to put the 3 gears on the bigger gear. Let me fish these out and we'll install them. I'm trying to basically go through and redo this from scratch. Oof. Well, that was nice. It went on and then it came back off because there's plenty of grease on there. Now, carrier goes in the, put a ring on it, and don't forget the lube. Oh, there is plenty of shiny lube in there. So don't need to worry about the lube. It is all over the place. Hey, Blue Chocolate Bro, you spent 30 minutes or so looking and you don't see it in your workshop. Okay. Fine, decide what I'm assuming Voron build to do mod light. There's a spring. We need to put an ECAS in it. We've got an ECAS in it. We've already done that part. Now we need to put one of the bearings in the inside of this piece. Plate should slot into the specific space on the gearbox. There are two aligning tabs to help with this. Yeah, there's the aligning tab, top and bottom, to enable that to align. Okay, so this needs to go on back on this. Align the moon and stars. So we got that back on there. Why is that? Okay. That's back on there. Things still move. Things still move, so that's always good. Go through bearing. Go through, there we go. Go through bearing. Now we need to align our pieces there. Our little gaps here are lined up in the printed part, which is going to keep this black plastic piece from moving around. And it says to pull on this to make sure that it's pulled forward and properly aligned on the bearing. Done that. Pull the planetary carrier forward while aligning the filament path. This lets the planetary carrier rest on the inner ring of the inner bearing and line the tolerance correctly. Okay? Did I miss something? Okay, there's the drive gear getting added on. So drive gear gets added on with the hobbed piece closer to this back plate. Make sure you line your set screw up with the flat of the drive carrier. There we go. This piece here, we need to get the other bearing pushed down into its spot. Probably would have been a little bit easier to do without having the things in there. Definitely would have been easier to do before having the last one in there. Let's take that out. You're going to build a switch wire? Okay. Switch wire can be a good first build. I would suggest it over a Voron, even though, or excuse me, a Voron V0, even though I did a V0 as my first Voron build. Yeah, was there, you just can't read. You're not the only one that has missed the reference there, Noah. All right, why are you... Not a good idea. All right, so how? Definitely going to be a tight press fit in there. I'm going to try and go in there and scrape out just a little bit of snot on that edge. Got 90% of the build for a switch wire. There you go. Why are you not going straight down in there? Trying to look for any little blob or ledge on the part that needs to be removed to allow this to sit down in there nice. It's going to be a tight push fit, that's for sure, as bearings are supposed to be. But if it's not sitting flush when you go to push it down in there, it will not go in nicely. Let's clean that off without pre-slicing ourselves again. Because I did bleed earlier. We did draw blood. This is a proper 3D printer build now that we have drawn blood. Now I wonder, should we just put that down in there, flip this on, and press fit it this way? Catching. Okay, so these have the tall heads on them, and that's fouling the getting it past the bearing. So we probably, at least on these ones, need to go with the flathead which sucks because I like these a lot easier. They're a lot easier to use than the small flatheads that use Phillips screwdrivers. I strip the heads out of those almost every time I use them. But I've got a bunch of them, so into the kit we go. Will be much better. I don't think I'll be able to get the second one in there regardless. Okay, there we go. That allowed me to get the bearing in there. Now can I get it back off with the bearing staying in the part? I did. I did, I tell you. All right. So now we've got our bearing down in there. It's not 100%. Okay. We'll loosen that up and let it go all the way down again. Wind up on the bearing. Now there is a wire channel on this gray part, and we need to make sure that our wire for our end stop goes up and through said channel. Probably be easier said than done. It's not lining up, so. Okay, there we go. We'll get the drive gear at the appropriate spot. M3 by 25 and M3 by 35. 25 and 35. That already have those screws here. 20, 20, 20. Then I don't. So I need 25 and 35, right? 25 and 35. 25 and a 35. $35 at the top, 25 at the bottom. And these will be the screws that are going all the way through and into the motors. And of course, this one is going to need to be probably a 35 as well. Hmm, 30 might have done it, but 35 definitely does it. Take a quick gander and see if 30 does do it. 30 will go through, but it won't provide any threading out the back. So I am going to use a 35 because we will need to attach some standoffs for a board mount. So in fact, this one may actually get increased to give us a little bit more meat for a board mount rather than just maybe 2 threads. Like this one really gives us a good mount that we can screw in a standoff. So those 2 are done. We still need to align our gear on our filament path. Right, we're nowhere close on our filament path, and my lighting option sucks. So what I'm going to do is get this forward lined up on the filament path. I will run some filament through the path to make sure that we are in alignment. Where was yours? There it is. So there we've got very crappy lighting. There we go. So I've got it lined up with the filament path going right through that piece. Now we can go ahead and cinch down the set screw on the flat, and that will ensure that we stay lined up there. We can move our knob back and forth and get our filament going in and out. So there's that. We need to do our pull the planetary forward while aligning the filament path. Yep, yes we did. Everything is working smoothly. I'm not feeling any binding whatsoever anywhere. The MR115 bearing goes into our slot, and then our pin goes in. Our pin was seeming to be really tight. So this is a so that should be a M5 hole. So what I'm going to do is feels like it's slightly undersized, and what I did was I took a reamer and reamed about halfway down this side of it. So I should be able to put my bearing in there, get my pin lined up with the bearing, and get it started. Now it's starting to get tight. So now I can push it down the rest of the way. Maybe. Maybe not. I'm going to have to ream that all the way, because it's just not going in. So we'll ream it all the way. Yeah, it should fit nice and snug, but I don't want to jam it in there and crack the part. I'm with you. I don't want to ream it all the way through, but I do want to ream it to where it's pretty darn close. Yep, and that's going to work just fine. M3 by 20. Well, we got a bunch of those. We can do an M3 by 20 there. Now that is a pivot pin, so you don't need to ugga it. Make sure it's down there and tight. You still get good movement there. So thumb screw tensioner. Once again, I'm not really cranking it, but I go until the tension hits and I feel like I bottomed out. Then I do one full rotation off, and that gives me my starting point for the tension. That's how I do all of my extruders. I don't know who may have mentioned that to me or who I picked that up from, but it was probably a Steve Builds tip. I don't know. I get a lot of tips from Steve. Now to fit a sliding assembly in the Y-axis of the baby belt. Okay, put the little extruder knob on, and then we'll be done. Now my extruder knob was a little snug. Ah. So we'll keep yours on there for now. Maybe I'll reprint this at like 101% so that we can get the gray on there instead of the other one. Yep, no sense in jamming it on there. I'll reprint that. For now, we'll put yours on there just so we have the extruder complete. Yay, we've got the new extruder in there. Okay, so GW2 is back assembled. Now we have to basically assemble everything onto the printer. I am going to, actually, let me see. This was the board mount that I had picked up since we're using the EBB36. We try and see how that's going to go on there. Like, it'll go on there like that. And let me see which is the longer of these two. This is the longer one. Let me measure this real fast and see where we're at as far as length. And that'll define what size standoff I use on the other side. Burn it. 22 millimeters. Okay. 22 millimeters. Do I have a 22 millimeter standoff? I do know I have a bunch of standoffs. Worst case scenario, if this is not like 20, then I do have a nylon one that I can use. That is a 20 millimeter standoff. Size is this one. So one's 18, one's 22. That's awesome. Perfect. Okay. I'll have to think through that. One's 22. Oh, sure. Waters, go ahead and send them over. And Steve, I did use your design for the bed and fan Wago mounts. That came out really nicely. Appreciate you sending that over to me. Let me see. I'm not going to hate too hard. So I think what we're going to do next is belting of our axis. Once again, using this carriage, because using this carriage and this mount on the standoff will be fine. Now this is actually made to do heat sets from the looks of it. I wonder if I could just bore it out and sleeve it over the top of the standoff. I think what I can do, because that'll be perfect. We'll want to do this one with that one anyhow. So I think what I can do is I will reprint this and I'll just cut 2 mil off, and that'll make this 20 mil to match my 20 mil standoff here, right? Because this one will wind up being just a little bit longer. So I'll cut 2 mil off this and make it 20 mil. That should be perfectly fine to give us our offset for our mount back here for EBB 36. And yeah, we should be good to go there. And then we'll be able to start putting some things together. I will most likely go ahead using the jig here and get our LEDs wired up. I know you provided an RGB and several sequins. I was going to use this LED mount that are in the files, so we'll add the 2 LEDs here. This is going to go in at the, which way does that go? it should slide in just like that on the front cover. So from the front, it won't be noticeable. And it'll shine light back down onto the nozzle. So we've got that stuff ready to go. I did see that you had the diffusers and stuff, several of them, already printed for dropping into the front here. In fact, we can drop that in there already. That in there and press down so that the diffuser's already there. Now all we'll have to do is get our LED done, and we can put our LED shuttle in there. Why not do the... There is a carrier for that, right? Yeah, I don't have this. I don't have that LED carrier. So I need to print that part as well. So I got a couple of small parts to print, but I think we made some progress. No, trust me, I've got LEDs. I just know that there were several. Let me get some things out of the way here. You had a couple of different, like, yeah, see, there's plenty of LEDs in here, right? I just also know that you had the sequin style LEDs in here, but these are not, I don't have the printed parts for these. And I'll be quite honest with you, I don't think I'd want to try and do those. Yeah. These are hard enough for me to do. Trying to do these little sequins, I think I would lose my mind. But there's plenty. We've got these. Don't worry about those. I've got these. What I don't have is... Yeah, so we got more sequins too. I don't have the actual board for the PZ probe, which is the part that I'm more worried about, is not having that board. And like I said, I'm going to have to go back and look at my videos to see if I somehow did something with it. I don't think I did, because I just kept seeing the package here and just moving the package saying, yep, we've got it. Yep, we've got it. And now it's... the board is not in the package, because this was the magnets, the DSI display stuff, the Legos, end stops. I have not been using these end stops. I've been using these end stops. Kind of like these better. JST connectors, okay, or JST microfit connectors. Yeah, so I don't know where that board went. But yeah, it is just definitely not in this package. which is where I assumed it would be since it's the PZ probe. Which makes me sad. Okay, I appreciate it. Some are RGBW, others are just RGB. Yeah. And like I said, I have yet to solder up the sequins, and I have, I'll say, specifically stayed away from the sequins because they scare me. Kind of sad to actually admit that, but they do. Okay. So I think what's happening is that's kind of where we're at. That's where we're going to stop tonight, because before we do anything else with our tool head, we're actually going to have to mount it on the printer, which means we're going to have to belt the XY or the AB. We're going to have to belt the carriage and mount our carriage mount, right? So we'll get that going. I'm going to reprint this part, which is the standoff / mount for the PZ board. And there's another part here I'm going to reprint just because I realized that the orientation and the cooling on the printer I used is dog do, so this needs to be reprinted. This is the like hub mount for on the forehead side. So I'll redo that. And yeah, other than that, I think we made good progress today. We're ready to go. Thank you for being here and hanging out with us. Using the OmniFixio. The issue is my eyes. That's what it is. It's just all about me and my eyes. But thanks everybody for being here. Thanks for hanging out. Sorry for the late start. Like I said, my allergies were kicking my butt. Waters can tell you I was sitting down at Ecovate with him, and I was a mess. So thanks for hanging out. I will see you guys on Thursday. Cartoon Anarchy, how's it going? Anyone know where a Merc Hydra bed could be got for $255 or a $275? I believe I got mine through Fabreeko. Now, whether they have them, I don't know. Yeah, everywhere seems to be out of stock. I believe I got mine through Fabreeko. I'm almost 100% sure. But yeah, they may be out of stock right now. And it's possibly because the majority of them are being made not in the US. Which means there's supply chain issues getting them in. And when they get them in, they're going to be expensive. So you could probably find them over in Ollie. Just be careful and make sure you pay attention to what shipping is going to cost you to get them in. That's the biggest thing. And like my Inner 3 NG build, I've got the all metal carriage, like bed carriage. I've got the Mic 6 build plate. I've got an oversized magnet that I can trim to size, and I've got the Honey Badger spring steel sheet. What I don't have is the heater, so I still need to source a heater for that. So because Fabreeko was out of them, so I'm still trying to source a heater for that particular build. But that and a donor printer, but I have a couple of lines on donor printers. So Yeah, and it's not the shipping cost, it's the tariffs that's adding to that shipping cost. Yeah, I wish KB3D could get some more in, but really it's KB3D and Fabreeko for your 0G parts. Yeah. So, all right, folks, that's all I've got for you. Waters, I don't know if I'm going to go down there tomorrow or not. I got to check my schedule and see what it looks like. Well, if anything, if I go into town, if I go into Raleigh, I'm going into the office first. And then I'll let you know if I'm bouncing over. Oh, yes. Yes, the shipping's heinous right now. Let me snooze that ad. And folks, we're going to go ahead and figure out who to raid over to. It is Tuesday night, which means it's normally a Jano night, but at 10:30 at night, and Jana was in our stream. He may not be up and running. We may be going over to Zombie, who I see has started. Yep. So I haven't been over into Zombie in a while, so we're going to get ready and jump over into Zombie. Looks like he's talking about the bamboo printer sale probably. But thank you everybody for being here. Come along with me as we go over to Zombie Hedgehog. Feel free to heckle them or, support them. But thank you all for being here tonight. We'll come back Thursday night. We'll belt the gantry and we'll keep going on this tool head. We're making some good progress. So take care, everybody. Have a great night. Stay safe, stay dry, and we'll see you on Thursday. And for those of you that are watching this later on YouTube, thank you for sticking around. If you like the content, please be sure to like the video, subscribe, and when you subscribe, hit that bell so that you get notified of future videos. And speaking of future videos, YouTube's going to be suggesting a new one right over here. Thank you all, and have a